Now we are going to study the third type of the failure in the road known as the low temperature cracking. For the description of this low temperature cracking, we need some definition: stiffness, then we have to know the creep, we have to know the creep stiffness, then we have to study the slope of master curve. This stiffness is a property related to the road. Load is exerted at the point at which deformation occurs. Try to understand. The load is exerted and the point at which deformation occurs, that is known as the stiffness point. These are just small definition. This creep, failure due to stress. Clear? Just creep, meaning of the creep. It is the property of the material showing the failure due to stress. This creep stiffness is represented by ST. And this slope of the master curve is represented by MT. Here, we are going to study the stress produced in the road due to thermal contraction. Let me explain it. Stress produced in road due to thermal contraction. Okay. If this stress is increased, cracks will happen. Clear? From here we can say that higher ST value, more susceptible to cracks. Next, ST is studied at low temperature. How much is the temperature? Like critical temperature, plus 10 Celsius. What is the critical temperature? You know, my binder is PG 82 and negative of 22. Here negative of 22 is critical. So here then I can write down negative of 22 plus 10 is equal to minus 12. So this is my important temperature at which I am going to study the value of ST. Clear it? Third point, this stiffness increases with aging. It increases with aging. So this creep stiffness and the slope of the master curve are the two component elements used to study the flexibility of the asphalt binder at low temperature. Let me, if you want, I will just write down its above these two parameters. Above these two parameters are used to study the flexibility of rod of binder or slash rod at lower temperature. Why I have written this definition? Sometimes in the interview this question is asked that what are the parameters used to study the flexibility of the rod at low temperature. Its answer is just say creep stiffness and the slope of the master curve. Clear? Now this slope of the master curve, what is this? Empty. Here I would like to tell you, slope always shows the change of one quantity with respect to other. So it shows how the stiffness will change with the passage of time. It shows how ST will change with time. It is drawn between log of ST and log of time t. Clear it? Now, when we have done this, and this test is always performed, these values are always studied for the material taken from long-term aging. And the specification always has described their values, like for the creep stiffness ST as 60 means 62nd time. Its value is 300 megapascal. It is the maximum value. It means we will not have to cross this value. Similarly, MT, this slope value, slope at 60, its minimum value is mentioned 0.3. So these are the, if my value is exceeding this one, it means material is no more acceptable. If my value is dropping down this one, it means material is no more acceptable. So these are the boundary limits defined in the specification. We have to study our material, then make the comparison that which one is good for us. Okay, this was just brief introduction, brief definition. And now, this test is always performed by bending beam rheometer test, BBR test. Bending beam rheometer test. So this just and the temperature, as I have already given you what should be, okay, minus 12. How this minus 12 Celsius come, and I have given you in calculation. Thank you very much for seeing this.